Hey guys, Mr. C here, and I'm going to show you how to find the domain of a composition function. This is actually one of the last examples of the section 6.1 note packet. It should be found at the very top of page 4. So what we're going to do here is a couple of things. Number one, we're going to find the composition f of g of x, and afterwards we're going to go ahead and figure out the domain. So as we kind of discussed in class, when you form a composition function, you have to worry about the domain, and I'm going to go ahead and review that technique for figuring out the domain. So first things first, let's go ahead and figure out the composition function. So f circle g of x. And I would push you to rewrite this as f, and inside the parentheses of f, we're going to write the notation g of x. Alright, so in simple terms, we're basically going to take the function g of x and plug it into the function f of x. So what I'm going to do is just kind of illustrate that, some arrows here. So we're going to take 2 over x and plug it into the only x that's part of the function f, which is in the denominator. So what I'm going to do is next is just kind of tweak this composition notation just to show you what's really going on and what we're really plugging into the function f. So let's write f. And instead of using the notation g of x, let's be a little more explicit about it and put 2 over x. Next thing we'll do is write out what f of 2 of x is going to look like using the equations. Alright, so I'm going to start with 3 over, and instead of x minus 1, remember we're replacing it with 2 over x. So 2 over x minus 1 is what that's going to turn out to be. What we're looking at right now is actually an example of a complex fraction, and the reason that it's a complex fraction is because we have a fraction nested within another fraction. So for instance, we have the smaller fraction 2 over x, which actually happens to be in the denominator of the larger fraction. We typically want to simplify that, and I'm going to show you just exactly how you can do it right now. The key is to actually figure out what you would need to do to get rid of the x that's in the denominator of 2 over x. And of course, that would require us multiplying this fraction by x. But if we multiply this fraction by x, we're also going to have to multiply the negative 1 by x. So here's what's going to happen. Let's go ahead and write x and surround the entire denominator in parentheses. Of course, our distribution kicks in. But what's going on behind the scenes when we put x in front of a set of parentheses here in the denominator is that we're multiplying the denominator of the larger fraction by x. And so what that means is we'll have to follow that second golden rule of fractions, which says whatever you do to the bottom of any fraction, you also have to do to the top. So anyway, what that works out to be, or what I'm trying to allude to, is that if you're going to multiply the bottom of the larger fraction by x, you should probably do it to the top as well. Alright, so things are going to clean up from here. First of all, the top is going to be x times 3, which is 3x. And on bottom, when you distribute and multiply x to 2 over x, what's left over is just 2. And then multiplying x to this negative 1 will leave you with minus x. So that's the preferred version of the composition function. There's no more simplifying to do. And that's what the composition f of g of x looks like. Alright, so that takes us to step 2, where we're going to find the domain. And as we were discussing in class, we have to first find the domain of the function that we're plugging in, d inner, and then move on to find the domain of the simplified composition function. And then we have to form the intersection of these two number lines, or these two domains. And that's what this third bullet point is for. This is for the official domain for this problem. So d inner is going to refer to the function that we were plugging in, which is g of x. But more explicitly, it's really 2 over x that we're plugging in. So that's going to be what we want to find the domain for in terms of d inner. Now just looking at 2 over x, there's one bad value of x that we should avoid plugging into this fraction, and that would be 0. So I'm going to go ahead and write out that, well, we can use anything we want so long as it's not 0, or symbolically x cannot equal 0. When you put this on a number line, since that's the only value of x that we can't use in g of x, it means we can use anything that's to the left of 0. And when you get to it, put parentheses, and you can use anything to the right of 0. Okay, so that's the domain of the inner function. We then move on to find the domain of the new, and this is really just the simplified composition function. And what that's going to refer to is our answer from step 1. All right, so now looking at this fraction all on its own, you'll notice that there's an additional value of x we have to avoid, and that would be 2, because if you plug 2 into this fraction, we'd get 6 over 0. So with regard to the new function, we want to be sure that x does not equal 2. All right, so I'm going to draft up a number line for that. And I'm going to place 2 a little bit further to the right on this one, just to have some sort of relation to the first number line. And in terms of shading, since this is the only value of x we can't use in the new simplified composition, we can use anything that's less than 2, parentheses on it, parentheses, and we can use anything that's greater than 2. So for the official domain of this composition function, we have to find the intersection of both these number lines and keep what's in common. It can be a little bit tricky, especially when we have these different parts of the number lines being shaded that don't perfectly line up. So in a case like this, I think it's much easier just to look at what we wrote out symbolically instead of our graphing. So for example, based on the inner function, we don't want x to be 0, and that has to be true throughout. So we need that condition to be met still. But in terms of the resulting composition function, or the simplified version of it, we also don't want x to be 2. So that still needs to be satisfied as well. So there are 2 conditions that need to be satisfied, and those would be x cannot equal 0 and x cannot equal 2. And these are actually the conditions that will be the official conditions for the composition function. So what we do next is we plot these on this third and final number line, so 0 and 2, and then we just shade the appropriate parts. So again, since we're not using 0 and we're also not using 2, and these are the only 2 numbers that x cannot equal, it means everything else is fair game. So anything less than 0 is going to be part of the official domain of the function. Anything that's between 0 and 2 can be used, and anything that's larger than 2 can be used. And again, just using some parentheses on these endpoints here. All right, so let's go ahead and whip this up into interval notation to get our official domain for the problem. Negative infinity, comma 0, parentheses, union, parentheses 0, comma 2, parentheses, now union, parentheses 2, comma infinity. And that's our domain in interval notation. All right, and that's how we take care of this example. Thank you for watching.